Hello, AP Statistics class. We're going to look at our first two means examples today. So we're going to look at this situation where we have a random sample of 13 men and 19 women. And then we have a woman in this class. So this is a class, some college class. And I guess if it's a random sample of 13 men out of that class and 19 women, this must be a large class. So I'm going to make note of that. I don't know how big. It must be one of those surveys, like 200 kids or something like that. I don't know. But anyway, we have information on these students' basic GPAs at this point in their college career. We don't have the raw data, but we do have the summary statistics down here, and we do have histograms of separately the men. I think that's why this means M. And we have histogram for the women's GPA as well. So I think we'll be needing that in order to address some of our assumptions for this hypothesis test. So this is the first time pretty much that we're going to look at a two-mean test, because a woman in the class claims, she makes a claim, she believes that college women tend to have higher GPAs than the men do. So we're going to see if this sample supports that claim. So let's look at setting up our hypotheses. So first of all, I think this is definitely a problem where our population of interest is a little bit interesting. So what is our population of interest here? I think that, they didn't tell us a whole bunch up here. They just said like a college class. So I'm going to say college, I'm going to say maybe college students in classes like these, if you get me. So I don't think we can extend our results, whatever we get, much beyond that. So our population of interest is a little bit vague at this point. So anyway, we don't want to extend our results too far on this one. So let's set up our hypotheses. So here we go. So H sub O, our standard null hypothesis. So I think we've got two means here. We've got two groups, the women and the men, and we'll just check to see if nothing unusual is going on. We'll look at mu sub, I don't know, mu sub women. We'll say that that's equal to the men's average GPA. I guess I should say the variable of interest then we're looking at is GPA with whatever GPA units are. Okay, so our alternative hypothesis, this lady thought that she thought women were higher, so I think we'll go with a one tail and say that the women's average is higher than the men's average. Okay, so let's look at our assumptions. I think I'm just going to type that one out if you don't mind. So let's see. I'll get some assumptions going here. So assumptions, what do we got? Let's get that bolded. There we go. Maybe I'll get some bulleted list going here. Yeah, that's okay. I'll just get like that going. Okay, nice. Alright, so to establish independence within groups, I think we're going to have to do a couple things. So, we need to see randomization. Do we have a random sample for each? So we were told these samples were random, the men and the women. I think that's a little questionable, but okay. We need to check the 10% condition. So I'm just going to kind of be a little bit brief with my assumptions today. The 10% condition, just to make sure we're not sampling too much of our populations. So I'm going to say each of these samples definitely represents less than 10% of the respective, is that a word? I don't think I spelled it right. Respective male and female populations who take classes like these. I mean, even if we were just at a smaller school, over the years, that would probably definitely apply. Maybe we're just trying to extend our results to this particular year. But I think if this is any kind of size of school, we can definitely extend the results at least to the classes like these within that school. Whether we can extend them beyond that school is another question. So I think we're pretty safe here, though, as long as we're not extending beyond that school. Anyway, the other assumption we need to make is the R, so groups, I'm just going to say it like this, groups of, oh man, if I can spell groups of male and female students, put the word these groups of male and female students shouldn't have interacted with one another and should hence be independent of each other. So that's that assumption that we saw when we did double proportions. You got to make sure groups are independent. And then of course we need to, probably most importantly, address the nearly normal assumption. So this time we don't have raw data, but we do have the histogram. The samples are relatively small, so we can't invoke the central limit theorem to say that the sampling distributions would necessarily be normal without looking at their histograms. But I think we can, since we already have the histograms here, we would have to sketch it. If you have a problem where you don't have them, you need to sketch those histograms, either for one or two samples, and talk about them. But basically we have these sketched already. The men's histogram looks definitely symmetric and unimodal, so it's nearly normal. And the women's is a little bit maybe skewed to the left, but it's basically unimodal, somewhere the mode's somewhere in around here on 3.25 or 3.4 or something like that. And it's roughly symmetric, so we're good to go. So I'm going to say, considering the histograms above, the men's is certainly unimodal and symmetric, and the women's is also roughly symmetric and unimodal. Hence, each is nearly, or approximately, make sure you work that word in there. If you just said normal here, you would lose points. So is nearly normal. So I think we're pretty safe on this one. Remember, this is the nearly or approximately normal condition that we're checking. Get symmetric spelled right, and there we go. So just one other note I wanted to make note of was that these two assumptions right here, these establish independence within, so I'm going to say within groups, and this guy establishes independence between groups. So that's something you definitely need to do for two means or two proportions. And then the nearly normal thing, of course, is just for means in order for us to be able to use our t distributions instead of our z distributions. Okay, so let's actually start getting to the calculations now. So I'm going to scroll down a little bit, and I'll switch back to black, and we'll create our t statistic for this test. So our t should be just like you've done before. It should be like your statistic minus your parameter over some sort of standard deviation. So if you're watching the video, I'd encourage you to pause and try to look for the standard deviation that you're going to use for this problem. But our statistic is going to be the difference between our means. Now let's go back up here to the beginning and look at our hypotheses to give us a hint. So remember, you can use this and think about, well, if I just go mu sub w minus and subtract this one to the other side, I'll have a nice way to think about this. So I'm going to be looking at the x bar for the women minus the x bar for the men, and that's all my statistic. And then I'm going to be subtracting the parameter that I assume in my null hypothesis, which is 0. And then from my AP Stats card, I'm going to pull out the proper standard error or standard deviation for this guy, the estimate for that. So I'm going to say the only way I can estimate this is using the sample standard deviation for, let's go be consistent here, the women, square that, divided by how many women were in my sample, and do the same thing for the men. And there we go. So remember, this shouldn't be unusual. If you remember, for one sample, it was the standard deviations of the sample divided by the square root of n. That's basically the same thing as writing it like this, and that is exactly what this looks like. Variance rules that we studied earlier in the year say that when you add two samples of variation, you have to add the spreads. We go back and look at that derivation and derive this guy, but I think it makes pretty good sense. So we're going to go with that. So let me move this out of the way, and we will go ahead and calculate this. So I'm going to put my numbers in from my calculator, and the women I think was what, 3.330 minus Let's just go ahead and go to our calculator now and put this in directly. So here's my calculator. So I'm going to go and put this guy in. So I'm going to get a fraction going here, alpha y equals. On the top I'm going to have the women's average. And I'm going to subtract the men's average. And I'm going to subtract 0. Of course. Oh, did I mess up? Darn it. And I don't really have to subtract the 0. So then I'm going to have over the square root. I guess I'll go down here and select my square root. And inside I'm going to have a couple fractions. I'll make this look nice with alpha y equals. So I'm going to have the women's 0.395 squared over, I think there were 19 women, and the men's sample standard deviation. Well, let's get another alpha y equals. Okay, and it was 0.583 squared over 13. Okay, and that should be my test statistic. So my test statistic this time came out to be 2.331. So there we go. Let's come back over here and get my eraser going, and we'll just type that in. So that's our t statistic. It's going to be 2.331. So how many degrees of freedom do you have in this case? Well, there's a complicated formula for degrees of freedom. I guess I could have gotten that ready for you, but it's in your book. You can look up the degrees of freedom formula. It's going to be this big complicated thing. Let me go see if I can find it on the internet real quickly here. Let's see. So we'll say 2 sample mean hypothesis, 2 sample mean t procedures, degrees of freedom formula. So this is in your book. I'm not going to go ahead and use this formula right now, but we might use it on a couple problems. There it is. There's the degrees of freedom formula right there if you want me to zoom in a little bit. So it's pretty ugly. It's not difficult to do. You've just got to put the samples in the right spots for the men and the women, and you've got to put the sample standard deviations in the right spot. But the calculator can do this for you, and I think we'll mainly rely on our calculator this time. So I'll just tell you, if you put this into that formula, put your numbers in this time, how many degrees of freedom do you get? I think that we are supposed to get 19 degrees of freedom, so let me just mark that down. So from the formula, this time the degrees of freedom are going to be like 19.44. So we'll be more conservative and just go with 19. Okay, so let's go and figure out our p-value from the table, and then we'll go back and have our calculator confirm that. Because I like to be able to do it both ways. You definitely need to be able to do it both ways for the AP exam. So we had 2.33 and 19 degrees of freedom. So right here, not big enough. There's 1, 1.3, 1.7, 2.0, 2.2, 2.5. So it's between these two guys right here. So since we're doing a one-tail test, the tail probability is going to be between 2% and 1%. So let's go and mark that up here. So our p-value from the table is less than 2%, but it's more than 1%. Okay, so that's a pretty small p-value, so I'm going to go ahead and reject. And we'll just write that down, and then we'll go confirm and see what it says from our calculator. Okay, so let's write our conclusion first, because we pretty much already know what we're going to do. So since this p-value, or probability of seeing what we saw, or something even more extreme, if the null hypothesis was true, since this p-value is quite small, in fact less than 2% in fact, we reject H sub O. There, oh my goodness. There is sufficient evidence that college sorry about that, women in classes like these have higher average GPAs than men in classes like these. So it looks like that lady was on the right track, at least for this population that she was thinking about. Could you extend this to other places? Could you extend this to other types of majors and things like that? Definitely not without doing some more research. Let's go ahead and confirm our p-value with the calculator. So I'm going to run this test on my calculator. I'm going to go to Stat, over to Tests, and this is a 2-sample t procedure, so it's a 2-sample t-test. Now let's just enter the statistics since we didn't even have the raw data, so let me pull that up right here. So there we go. So what do we have for the women? We're going to go 3.330. I don't think it matters which one I put where. That sample standard deviation was 0.395, and we had 19 women. The men was 2.898 and 0.583. And how many men were there? I forget. Let's see. My calculation had it in there, didn't it? No, it didn't. Let's scroll up and see. 13. Okay. And now I need to go down. We did a one tail above test. We're not going to mess with pooled for this kind of thing right now, so we'll talk about that another day. And we'll say calculate, enter. And there you can see the t-value is 2.331. I think that's exactly what we got down here, right? 2.331. P-value is 0.015. That's smack dab in the middle. Doesn't have to be smack dab in the middle. But if you go back to our table down here, you can see that the 2.33 was kind of right in the middle of those two numbers. So it makes sense that the p-value is right in the middle of the two edges. So everything's making sense here. So it looks like we made the right conclusion. All right, to finish and wrap up this example, let's create and interpret a 95% confidence interval. Okay, let me just get rid of this guy. Don't need this box. All right, so how are we going to do that? Well, we don't have to go through any of the assumptions again. Let's just go back and do it. Okay, so confidence interval. Well, what's that going to look like? That's going to be the statistic, which I think we said was the women's average minus the men's average, plus or minus our t star. We're going to do 95%. You know, let's just do we'll go 95%, I guess. So t star with 19 degrees of freedom right there, and then we're going to have the standard deviation that we had before, which is like the women's squared over the women's number plus the women's, the men's, sorry, squared over the men's sample number. So I think that's going to be what? It's going to be 3.33 minus 2.898 plus or minus, let's go find our t star, so 95% with 19 degrees of freedom is going to give us this number, 2.093. And then we're going to have the standard deviation here. So I'm just going to go and calculate that on my computer, and we'll write it down. So let's grab a calculator. You could, of course, do this in that same interval. Let me show you where I could do this the fast way. So let's go to Stat, Tests. You can also do intervals here. See, there's your z interval, your t interval, your 2-sample t interval. You know what? Let's just do it the fast way this time instead of actually calculating it that way. And let's see all this stuff is already kind of loaded in there for me. It's ready to go. That's wonderful. So 95% is the level they said. Let's just calculate it and see what happens. There we go. Oh, and there's our degrees of freedom that you can get easily without using the formula I mentioned earlier. And let's see, they have the interval right at the top. Let's make sure that they tell us what t star they used. Oh, they don't tell us that. I don't see it anyway. So it says 0.044.819. All right, so I'm going to say 0.045, I think it rounded to, and 0.819. So there we go. Let's just conclude. I think that confirms what we said with our test earlier. Remember, we rejected. So basically, let's just be casual about this. We are 95%, not 0, 95% confident that the true mean or true average difference in women's versus men's, I guess I should put an apostrophe there, GPA for classes like these is between 0.045, oh man, 0.045 and 0.819 GPA points higher for the women versus the men. So that totally confirms our rejection from earlier. It's not on both sides of 0, it's totally above for the women. So this confirms our hypothesis test from a moment ago. Okay, so there's your first example with comparing two means. I think you'll find that not much has changed. You've got that special degrees of freedom formula, which you're going to have to use this guy right here if you want to do things completely by hand. Otherwise, you can definitely start working your calculator in there a bit more. But make sure you're using the t-tables as well as your calculator so that you're comfortable with both. I'll see you next time.